For this circuit, we need to find the power delivered by the 80-volt voltage source to the circuit, and we will use mesh current analysis to do that. So I have done mesh current problems long ago, but I won't go into the procedure in detail again. So I will quickly review the procedure. So what happens in mesh current is we have three meshes here, as we can see, and we will assign each of the meshes as a current. So it will be a fictitious current in the sense like there is no mesh current as such. We know that branches, each of the branches has current, but there is no mesh current in reality, but we will assign fictitious currents like this. So what will happen as a result, let's call it I1, I2, I3, three meshes, three mesh currents. So basically we are saying these are the current through the mesh, but when it comes to one of the branches, say this one, the 5 ohms resistance, this branch, the current is actually I1 minus I2 in this direction, or we can say I2 minus I1 in this direction. Now each of the mesh currents, they have a direction as well, each of them. So what will we have to do, we will write Kirchhoff's voltage equation for each of the meshes, and for each of the branches what we will do, we will assign the current according to the whatever the current will be through that branch, I1 minus I2 or I2 minus I1. Now we can see that for the given meshes we have a sort of direction. So I1 is going in this direction. So when we will write the equation, we will write KVL in that direction. So we will traverse in that direction basically, and we will assume this is the mesh current. So we will assume the resistance, the current actually goes in this direction here, and in this branch, in this resistance, it goes in this direction. So the drops are accordingly like plus minus in the direction of the current. But the real current through 5 ohm resistance will be I1 minus I2, because there is another current from this mesh, we get I2. So since this current is going in this direction, so basically this will be the in opposition to I1. That's understandable, I guess. So for the first mesh, I will write the KVL. So we are going from here in this direction like that, in the counter in the clockwise direction here. So 80 volts is a rise, so I will write minus 80, maybe drops as positive and rises as negative in the left hand side. And then I have 5 I1 minus I2 here, I1. Then I will have for 26, I will have 26, and the current will be I1 minus I3 is equal to 0. So if I rearrange, I will see it will become 5I1 minus 5I2, then plus 26I1 minus 26I3, and on the right hand side the source, the voltage rise basically. So there are two I1s, 5I1 and 26. So if I add, it will become 31I1 minus 5I2 minus 26I3. These are the three currents, and this is the equation basically. So this is my equation 1. Let's call it equation 1. Now for the other two meshes, I won't write the equations like this. What I will do, I will do a shortcut, and the shortcut is like this. If we look at it in this equation, we can see the coefficient of I1 is 31. Basically this is the sum of the resistances in common in that mesh, basically 5 ohms and 20 ohms. These are the resistances of mesh 1. So we just add them and it comes as a positive value. So 31, 26 plus 5, 31 I1, and the other two mesh currents will come as negative, and the coefficients will be the common resistances. So for I2 the common resistance, we can see here the common resistance is 5 ohms, so that is coming minus 5 I2, and then here it is coming minus 26 I3, because this is the common between I1 and I3, so I3 is coming minus 26 I3, and I5 was common between mesh 1 and mesh 2, so mesh 2 current is coming as minus 5 I3. So I think that's understandable now. So what I will do, I will write the equations for the remaining two loops. So for loop 2 it will become sum of the, so basically there is no source, so right hand side will be 0, and I will write I1 first. So I1, the common resistance is 5 ohms again, so that will become minus 5 I1. Then I2 will be positive here because that's the mesh current, so that is sum of the three resistances, 5 ohms, 30 ohms, 90 ohms, so that will be 125 there, 125 I2, and finally I3 will be again negative, and we can see the common resistance is 90, so that will become 90 I3, 90 I3. So that is the third resistance. Finally equation 3, the equation for loop 3, mesh or loop, whatever. So this is equation 2, and for mesh 3 it will be I3 will be positive, I1 will be minus 26 because this is the common, minus 26 I1, that will be like that. Sorry, it's minus 26, then minus, that will be the common here is 90 again, so minus 90 I2, and finally plus will be sum of the three resistances, 26, 8 and 90, so that will become 124, 124 I3. So that is equation 3, and there is no source, so that is so that is just 0 on the right hand side. So now what we will do, there are three simultaneous equations and three unknowns, so I need to find I1 because that's the current through the voltage source, and that will give me the power. So I1 will be, I will use the determinant method, which is just writing the coefficients as determinants. So the coefficients of I1, like I1, I2 and I3 in terms of a determinant. So what I will do, I will write it, and then probably it will become obvious. 31, then minus 5, and then finally minus 26. So these are the coefficients of I1. Then the coefficients of I2, this is coming in the denominator. I2 will be 125, and finally the third one will be minus 90. And finally the last one, which is equation which is I3, the coefficients of I3 will be minus 26, minus 90 and 124. So these are the three positive values, 31, 125 and 124. This one, then this one, and then this one. So, and sorry, in the numerator what will happen, since I am trying to find I1, so instead of in the I1 column I will write the right hand side, which is 80, 0 and 0, and the remaining one will be the same. So basically this will be minus 5, 125. This is a mathematical thing, just the determinant method to solve simultaneous equations. Since there is three unknowns, so we are using determinant instead of going into classical just the orthodox way of solving simultaneous equation. So this is how first we write the determinant, and once we have written the determinant it will become easier. So I1, let's do the denominator. So here what will happen, this is just the determinant method, so we will just write the value, have to write the value of the determinant, 31 here, and then it will be, the coefficient is 31, and the multiplication will be 125 times 124, 125 times 124 minus minus 90 times minus 90, so minus minus will become plus, so minus 90 times minus 90 will be, I'm just writing like that, minus 90 times minus 90, basically twice, so maybe another bracket, so that's there. Then the second one, it will come as a negative, so I will have to write minus minus 5, and then we will have multiplied this one, which is minus 5 times 124, sorry, minus times 1 times 124, like that, minus negative of minus 90 times minus 26, so basically again minus 90 times minus 26. And finally we have the third one. Oh, I haven't completed the bracket there. Finally this one, which is minus 26, it will be minus 26 because it comes as a plus, but we have minus 26, so like that. And then we have to do minus 5 times minus 90, so minus 5 times minus 90, and then finally minus 125 times minus 26, so minus and then 125 times minus 26, like that. This is in the denominator, and in the numerator it will be easier because we have some zeros, so 80, when we do 80, these two will be multiplied and then subtracted from, this one will be subtracted from that, this is 90 actually, so 125 times 124 minus 90 times 90, so I'm just writing 90 just like the denominator. There were two minuses, so I didn't write it. Then the second one will become this one, then 0 times this one will be 0, and then minus this times 0 will be again 0, so basically it will be just 0. So minus 5 minus of minus 5 times 0, so that's gone. And then finally we have minus 26, so that's minus 26, and then that will be 0 times 90, which is 0, minus 125 times 0, so that's also 0, so that's gone. So we have this, something like this. It's getting very long, the video, so I will just once you do the calculation. So what I have got here is 592. I have done the calculation elsewhere, so I'm just writing what I have got there. 592,000 on the numerator, and denominator is 22994, then 00 minus 14800, and then minus 96200. So what I am finally getting is 592,000, and in the denominator I am getting 118400. So the result is 5 amps. So the power will be, this is the 5 amps, which is I1, the current mesh 1 current, and that is the current through 8 ohms, because there is no other current through 8 ohms, there is no other mesh here. So that's the current through the power supply. So we needed to know the power supplied by the source, so that will be VI. So 80 times 5, that will be 400 watts. So P supplied by the source is 400 watts. So that's there. Just double check the calculations here, but I have laid out the method, tried to do that here. So it's a very long video, but yeah, couldn't help.